Okay, this video is much longer than the time that you would actually have on the question. Once again, unless you are just set and ready to go and know all of the stuff, I could solve this in 20 minutes or less, but not that much less than 20 minutes, and I have a lot of experience with it. We're also going a little bit slower because I'm explaining all of the steps as I go through them, at least hopefully. Once again, you can do this exact same setup, not with the box cube system, but the box alone. I did go through, and if I have time, though I probably won't, I can do a video of trying to do this from the box alone's viewpoint. Now this is a great spot to be. We've got the velocity as a function of time, because that's one of the key things that we'll need, but that's not all that we need on this. In fact, I might actually check my notes on this so that I can see where I'm going next. So we've got our velocity as a function of time. Great. Let's see. So the next thing that I have on this, the last point is going to be, pardon me, trying to tie these together. So we are still looking for Fn as a function of time. So I need to go back to my normal force and work with this. Okay, let's see. I think I have some notes on here. Let me see if I can make full use of them. Let's see. So negative FR, okay. Right, so back what we had for, do I have that? Yes. So looking at my Newton's second law setup, I had the following. FR is equal to 2m times a. Here's where Cleophas and the train cars comes in handy, because the acceleration of the system also happens to be the acceleration of the cube, and it also happens to be the acceleration of the box. They all have the same acceleration because they're moving together, at least initially. Here is the other thing that I think is actually kind of clever. Part A1 asked you to find the acceleration of the cube, which is also the acceleration of the box, and it is also the acceleration of the system. So we have the following, that FR is equal to 2m times, well, my answer to part 1 was Fn divided by m. That is a true statement based off of analyzing the cube. Please note that this allows us to take our m's and cancel out, and we end up with the following, that FR, at least the magnitude of it, is equal to 2Fn. Okay, great. FR at any given point has a magnitude of BV, and therefore that would be equal to 2Fn. But this is BV at any given time, the velocity at that time. Now you can see, hopefully, where I'm bringing all of this together. So I have B times my velocity as a function of time, which we just found was V naught, this thing, e raised to the negative b over 2mt, the classic form. And then, let me double check that that is what I had. Great, over 2m. And that will be equal to 2Fn. Great. So now I divide both sides by 2, and I get the following, that Fn is equal to b over 2 v naught e raised to the negative b over 2mt. This is our normal force as a function of time. We are allowed to answer in terms of b, of v naught, and m. E, the exponential, is a mathematical term, so it is allowed. This is the final correct answer. Now, I bet that there's a possibility that this would be where you would get plus 1 point. This would be a 4, as I laid it out. Or they might even have it where if you get to, pardon me, a relationship here, that this would get you to plus 1. It is entirely possible, because this is complicated enough, this is a challenging enough one, that you might not have to get the correct answer on this part in order to get full credit. Or you might. It can be hard to say. I will say, not getting the correct answer, depending on what you filled in, you can get partial credit. Recapping that, in this case, starting with a derivation, beginning with presumably Newton's second law, because that's really the only way to go about this, and having a multi-step derivation will get you your first point, is what I would expect. The other point would come in by either setting up an appropriate differential equation or taking it one step further and separating the variables such that you can actually integrate with proper limits of integration. My bet is it's actually here, separating the variables, because that seems to be what the grading rubrics I've seen most recently then end up going with. And I would say that the last point is based around being able to take that answer and solve for Fn, possibly using previous answers, up to and including being able to get the full correct answer on that. Okay, the next part. That took a lot, but this is one of the most complicated things that's going to show up on the exam. Usually the differential equations are, so hopefully this gave you some insight into it. On the axes shown in figure 2, sketch a graph of the magnitude force of friction of the frictional force exerted on the cube by the wall of the box as a function of time t from t equals 0 until immediately before the cube reaches the bottom of the box. This sounds like a lot, but if you're familiar with it, so this would be A3, and we have the following. They want us to sketch. Great, love sketching. And down the middle we have t crit. As we said before, at the beginning, the normal force is great enough that we have a force of friction great enough that up until t crit, the cube remains the same distance from the bottom. In other words, the normal force is great enough that our force of friction is greater than or equal to the force of gravity, or at least could be greater than or equal to. Here's where it being static friction is important, because if it were greater than the force of gravity, well, then static friction would try and throw the cube upward, but that doesn't happen. So here is where static friction, being the lazy force, only doing the minimum that it needs to keep the cube from sliding, comes into play. So at the beginning, for the first part, and I fully expect that this is worth 1 point, we've got, this should have a value. They said sketch, not sketch and label. But we could take it one step further and know that this needs to be equal to mg from our free body diagram from earlier back. Though I believe there is 1 point for the first half of the graph up to t crit, you have a non-zero positive value for your normal force, and it just stays a horizontal line like this. Ideally, it should be marked mg, but they did not instruct you to label, so you don't need to do that. After that, here's where I don't know if it's going to be 2 points, and maybe there's one more point in that very messy derivation that we had above, or this could be 3 points. The second point, I think, would be for having a decay. So let's see, 1 point plus 1 for decreasing, and then one other point plus 1 for asymptote. Asymptotically approaching 0, which is what you would get from your decay. In this case, hopefully you've had some practice with some of the resistive forces where you have something slowing down, and eventually coming to a stop. And by that I mean after an infinite amount of time. Here's what the answer, I believe, should be. You do not have to include this because they did not say label, but I think this is likely worth 3 points, though it might only be 2 points, and they might have beefed up one more partial credit point in the previous part. I am pretty confident that the last part, part B, is worth 3 points. And let's take a look at that and round this out. Begin your derive an expression for T crit in terms of M, B, mu S, and V naught, and physical constants as appropriate. Begin your derivation with a fundamental physics principle or an equation from the reference information. Here is where, once again, while you were not instructed to draw a free body diagram for the cube, having the free body diagram can be very useful. Now that I've got that, I would do the following. My first step is to write out a fundamental equation of physics or principle of physics, Newton's second law, one of the very important ones. In this case, we would have the following. Before, any time from 0 to t, the acceleration in the y direction, so I'm going to be looking in the y direction. The acceleration in the y direction is going to be equal to 0 for the cube anytime up to t crit, at which point we would have the following. So we would have, let's see, we have a force of friction up minus the force of gravity, a single m, because we're back looking at just the cube. Oh, times our acceleration, but this is 0. So we end up with the following, a statement that I mentioned earlier, that our force of friction was just equal to our force of gravity. With this being the critical point is what we're looking for. The force of friction, we're talking static friction, could be replaced with F sub s times our normal force equals our force of gravity. And then our last step on this, well, not quite our last step, but mu sub s, we know what the force of, or the normal force is. We found that just a minute ago, which is here, this mess. Plug that in. 1/2, hopefully I can do most of this from memory, but we had b divided by 2 v naught e raised to the negative b over 2m times t. I think that's all of it. That's my normal force, equals mg. I'm going to go through and show this kind of quickly, but at this point, we have mu s, that's allowed, b, that's allowed, v naught is allowed, m is allowed, b is allowed, m is allowed, and g is allowed. Let's double check on that. M, b, mu, s, v naught, and g is a physical constant. These are all allowed. All I have to do now is get t equals some stuff. And I apologize, this is t crit, because I'm setting up that my force of friction is maxing out, and it is equal to mu sub s times the normal force, in case that's not obvious. Okay, so all I have to do is do a bunch of algebra and get t crit equals some stuff. So I'm going to try and do that real quick. We're going to end up with e raised to the negative b 2m t crit. I'm just going to call that tc to save a little bit of time. We're going to have 2 mg divided by mu s b v naught. Okay, great. And then I'm pretty certain I've got that divided by that, the 2 went up there, the v naught went down there. Looks good. Okay, great. Then I need to natural log of this to get rid of the e, and I would end up with the following. Negative b over 2m tc equals, natural log of 2mg over mu sb v naught. And then finally, tc would be equal to negative 2m over b natural log of 2mg over mu sb v naught. We've spent so much time on this question that if I were doing this as part of the exam, I should very much move on to the next question as opposed to double checking my units, but you could do a unit analysis to make certain that everything works out appropriately. It should, if this could be the correct answer. I think it is, but I haven't gone through and done the full check, but I do think that this is the answer. Okay. I would say one of two possibilities exists. So when it comes to this part, let's see, I believe we are instructed to derive, so there is a good bet that the first point is simply for taking, starting with, say, Newton's second law and doing at least one physics step. So by about here, we would have +1 for our deriving, starting with a fundamental physics principle, and then taking at least one physics step, actually putting in the appropriate forces or identifying that the acceleration is equal to 0. Step 2, I think, is going to be based around this, that identifying that at t crit, your force of friction no longer is less than or equal to, it is straight up equal to mu s times your normal force. I think that is probably going to be the key thing that the graders are going to be looking for to get the point there. And then the last point would be either bringing in your answer from part A2, if, I would say this would be if the last point on that, A4 actually, A4 was for a correct answer. Or I think that the third point for this section would be for a correct answer if the other one did not require you to get the correct answer. It is possible that you have to get the correct answer for both parts in order to get that. In this case, I would say that this one would probably say either the correct answer or answer consist with a, I believe that was A2. So if you got the previous part wrong, but you use that thing correctly, then you should be able to get this or have the correct answer. If they ask for the other one to be the correct answer to get full credit, it's possible that they may just say, hey, for correctly using what you had in the previous part, in this part, you would get this point. It's possible that you have to get both of the complex things correct in order to get full credit, but I'd be a little surprised if it was both. I bet it's only one of them. Okay. Here's a lengthy walkthrough of question number 1, but there was a lot of commentary and trying to repeat some key ideas and learning in here for either students that are preparing for a future AP exam or something similar, or if you didn't necessarily get this, hey, best to learn it now. I will say this, a lot of this same working will show up later in APC E&M. You just won't be using Newton's second law, you'll be using Kirchhoff's loop rule or something similar to that, okay? All right, hopefully that was useful. Until next time.